Good morning, good noon, good afternoon, and good evening and good night, depending on where you're watching. Thank you so much for joining us on our class. We'll be doing a follow up on what we did last time, which is wonderful. We want to focus on the labs, right? We were doing labs last time, and I want us to just get right into it. So, we are going to be working with a coffee shop, right? The narrative that we had agreed in class last time was that we are a company called Amakatech, and a coffee company has reached out, or rather, coffee shop restaurant has reached out to us in terms to make sense of their information, right? So we are going to be using the provided CSV files, which contain real life coffee shop transactions, which should span records from for at least a year, right? So we are going to go through a couple of steps, which is one, we first want to understand and select a data type. We need to ingest data into Google Cloud, right? Be it BigQuery or cloud storage. We are going to explore datasets using text AI datasets. We're going to engineer features using BigQuery SQL, right? And we're going to choose and configure a notebook environment, Colabs to be specific. And lastly, we're going to be trying to understand the identity and access management, the IAM, security for data access, right? From there, Mr. Morphe is going to take us through Apache Spark and when to use it. He's going to take us through how to train a regression model using scikit-learn and PyTorch in Colab. He's going to also teach us how to register and deploy a model on Vertex AI and track our experiment runs using Vertex AI experiments. Then lastly, how to evaluate performance, right? So the prerequisites of pretty much this practice is that we are going to need a Google account with access to Google Cloud Console, which is console.cloud.google.com, right? It's just something that we can key in here, as you can see, cloud.google.com, right? And if you click on it, it's going to send us to the main page of our dashboard, right? Our GCP product that we had created last time, as you can see, I'm in the AI Specialist Training Heights project that we had created. We will need billing enabled. Luckily for us, Google usually provides free credits for us to use in terms of practice, and two CSV files, right, in terms of downloading or rather uploading the index files and a Colab account, which is free. At I will provide the URL to access Colab, right? So first things first, let's try and understand our data type, right? So we had used, right, or rather we had settled on a data set that had contained records of coffee sales from a vending machine, right? So we're just trying to have a story, right, behind this work that we're trying to do. So if probably don't have access to the CSV files, please navigate to kaggle.com and to this user, Yaroslav, that has multiple upvotes, and it's available, it's free for you to download, so we can use it. So why do we need to understand our data set? Why is that important? So before we touch any tool, we first need to understand what kind of data, right, are we using, and what is the model going to do with our data, right? So now that we've downloaded this, right, and we found that it's a CSV file, and we found that it has rows representing single sale transactions from the coffee shop, we have found in the CSV file that there's a couple of columns that we will be working with. So first one is the date and time, which is the time dimension, coffee name, right, the product that was sold, right, money, how much was charged, the cash type, right, are we working with CAD or cash? And from here, I think from understanding what we're working with, we are going to be working with tabular time series data, which means it is going to be structured, right? So we're going to be working with rows and columns. We're not going to be working with images and or text, right? So this means that it is going to be a meaningful time order types of data, and the sequence in which the transaction happened is what is going to matter most for prediction, right? So what is the goal entirely? What is the real goal for us to do this? So the goal for sales prediction, right? Specifically, we're going to find out features about a day, right? The day of the week, product, recent trends. We're going to predict how many units of each coffee product will sell, right? We're going to predict a number, right? Which is going to leave us with this is going to be, we're trying to solve a regression problem, right? So why should this matter? Why is the data type important? Right? Because it's going to drive subsequent decision making down the line, right? So we figure that it's going to be tabular data. That means we're going to be working with something called BigQuery, right? Because it works well, especially with CSV files, right? We're going to be using time series data. That means we're going to be using features, right? When we're talking about features, we're talking about lag values and rolling averages, right? Lag values meaning yesterday's sales, right? Yesterday's sales. That's what we mean by lag values. And when we talk about regression, we're talking about the evaluation metrics, right? Not looking at accuracy, but we're going to look at how it comes up to a result. And then structured data, which is AutoML or AutoML Tabular or BigQuery ML, right? Which is what we're going to be using for the better part of the session. So first things first, we've already understood that our data is a CSV file, so we'll navigate to our dashboard. We're going to be looking for BigQuery, right? So let's go to BigQuery. So click on the hamburger menu and navigate to BigQuery, then click on it. And here you'll find your project name, right? So this is where our information is going to be, right? So the left panel will have our project ID, and on these three dots here, right? On these three dots, we are going to be creating a data set. So let's click on it. Let's create a data set. Awesome. So what are we going to name our data set? Our data set, let's call it coffee. Or what do we call it? What do we call it? It's called coffee underscore sales region. We're going to be working with what Mr. Morfeo was working with last time, which is US Central 1, Iowa. Okay. From there, we are going to create a data set. We're going to leave everything here in terms of it being default, right? So let's create a data set. Immediately, you're going to see our data set has been created. There we go. So coffee sales, right? So we've seen that it's appeared under our project name in the Explorer panel. So next thing, we are going to create a table within our data set. So how do we create a table? We could easily use this, where we could create a table. Hold on, let me just show you. We could easily create a table here, or we could click on this as well to create a table. So I'm going to click on this, create a table, or you can click on this. Either one is fine. So let's upload our information, the one that we downloaded from Kaggle. So if it's in your computer, you'll find that it's zipped. Can you just extract it, and from there you'll be able to use it. So I'm going to be able to browse. Let me upload index one. As you can see, it's CSV version. Let's not try and change this. If it hasn't recognized, please change it to CSV, because you can see there's other different types of file formats. So let's change to CSV. Do not change your project unless you want to migrate it into a different project. Do not change the dataset unless you want to change it to change the name of a different dataset that you want to work with, right? So what do we name our table? We are going to create our table, and let's call it index one, right? Let's call it index one. It's going to navigate to schema. Let's go to auto detect. Let's go to advanced options. Header rows to skip. Let's click on one. Let's create our table. Awesome. As you can see, it's already created our table. We can go to table. And there we go. We have our table. And in our table that we have noted that the columns and elements have been brought out from the CSV file. Right? We can do the same with the other data set, right? So it's the same way. Like we can just go to this, sorry, create a table, code, index number 2, auto detect your schema, create table, and there we have it. We have table 2, right? Table 2 also having the elements that we need, right? So we need to verify our upload. So we should see in our schema tab that we have our date time, cash type money, coffee name. In the preview tab, we'll be able to see the information that is carried within the uploaded information, the uploaded table, right? We can query the table as well. Let's go to index 1 again. It's the same, right? Can preview it, has information. So I want us to query our table to find out if it had uploaded things well, right? Right. This is just to verify that our upload was correct. Okay. So we're going to run our query. Don't worry, I'll be providing the query walkthrough later in with the team. Right. So, or feel free to just pause the video, then you can copy it. So let's go query. All right. So as you can see, we're just trying to verify, do we have the right number of rows? When was our earliest date? When was the latest date? So we're trying to figure out how many rows do we have. It should be 3,636, as you can see here. It should have a date period of at least a year from March 2024 to March 2025. And we need to know how many products, how many coffee products do we have, right, listed in our table. So let's run this and see if we can get this as an expected result. So we run into an error. There we go. 3,636, earliest date, latest date, number of unique products, 8, as you can see, which was what we were looking for, right? So we can close this and move on to the next part. So what we want to be doing next, right, is that, and just to understand something, when we're working with different data types, especially when we're working with BigQuery, BigQuery works well with unstructured data, right? But what happens when we need to store our data elsewhere for reference, right? We now use something called our cloud storage, right? That is where we store our storage for reference, right? We'll be using other tools in a few minutes from now, where we want to be seeing how do we reference our information if we need to be using it from a different point of medium. But it's all about backups. It's all about backup. So let's close this. Let's close our table, right? Because we've already used everything we need to use. So now let's navigate to cloud storage. Let's click on cloud storage. So just as a definition, cloud storage is Google's object storage, right? So think of it like a cloud hard drive. So we are able to store our raw CSV files here as a backup to make them accessible to other GCP services, right? Remember, we will be using our information, or the data set that we have for future practice and experiments. So if you want to be using it well and efficiently, please try and consider Google Cloud Storage, right? So let's click on create bucket, right? We're going to create a bucket called coffee bucket. Feel free to name yours, however, which way you want to name it. But for the sake of following what we're doing, try and match, because sometimes you'll find that some names have been used elsewhere. So just try and follow keenly so that you can replicate this on your own at another time. So I'll call mine coffee bucket one. Let's continue. I'm gonna keep it a US multiple regions. Awesome. Then we're gonna leave everything in its default setting. So let's create our bucket. Confirm. Awesome. Congratulations. We just created our first bucket. Tap yourself on the back because we are making great headway. So what do we need to do next? What do we need to do next? So we need to upload our information. Again, remember, we're going to be using this as our source of backup, right? So let's upload our files. As you can see, it's indicating that upload has started and it's completed. So let's close this, save it down, and as you can see, index 1 and index 2 CSV files have been uploaded. You can see the sizes, you can see the type of information that it carries, when it was created, and everything else in between, right? So our bucket now has information of our data that we'll be using. So where do we go to next now that we have our data, right? Where do we go to next? We'll be using a very intelligent tool called Vertex AI. So Vertex AI, in a nutshell, get you lost, it is acting as the machine learning control layer, right? What does this mean? It means it does not store data, rather it references it. Okay, so Vertex AI is Google Cloud's unified machine learning platform. It does not store your raw data, rather it just creates a managed reference to data in BigQuery or cloud storage. Remember when I told you, if we want to use information, right? If we want to use our information, our backup information, right? That's why we have uploaded it in Google Cloud Storage, right? We can also use it in BigQuery, right? Again, you always have to remember what type of data you're uploading to what tool and how is it supposed to help you give meaning to it. So Vertex AI, yeah, creates a managed reference to data in BigQuery or cloud storage. This lets us preview, understand, and prepare data for AutoML and custom training, right? So I want us to go to Vertex AI, right? Let's click on our hamburger menu at the top left. Let's go for Vertex, right? Let's click on dashboard. Awesome. Let's look for datasets. We can click on create dataset, right? Let's click on create dataset. Let's name our dataset name. So I'm going to call mine coffee sales dataset, right? So you have to select a data type. and the objective. So, given that we already know what we need, right, from how we assessed um, the dataset that we were using, right, from Kaggle, we know that it's a CSV file. We know that we are looking at a structured time series data, which is going to be in tabular format. So let's click on tabular, right? We can either click on regression or forecasting, right? Given that we want to predict future sales, let's click on forecasting, right? IOA, it's fine. Then we'll click on create. It's going to take us a few seconds. Okay, so remember, I told us we're going to be referencing. Vertex AI does not store information, rather references it. So given that we've already given meaning and created a table with BigQuery, let's click on select a table from or view from BigQuery. Let's click on index one. Continue. And there we go. There you have it. See, as you can see, it has the elements already captured. And then the only thing that we need to do is just generate statistics because we want to see if it has discerned, or rather if it has registered, right, our data set properly. So click on generate statistics. It's going to take a while, a minute or two. So let's give it some time. As you can see, it's done. Well, yeah, depending on your internet, right, and also depending on how fast things are on your end, you'll find it between 5 to 10 minutes, right? So as you can see, it's finished, and now we can get to look through each tab. So for instance, let's look at card, right? So here we can tell, right, it has mostly, sorry, yeah, in our Analyze tab, right, we can look at the shown column level statistics, the mean, maxes, null count, and distribution charts, right? So if we look at the money column, if we were to look at this, right, you'll see that it has already calculated the range between 15 to 80, right, with most values clustered around, right? And if we were to look at coffee name, right, we'll see a bar chart which our products appear, right, from Americano to a latte, right, which should appear here. And we can also check for our nulls and the card segment showing us, or the card column showing us nulls for cash transactions, which is expected, which is fine, right? Which is fine. So what we're going to notice is that the money column has a right skew, which indicates a few large transactions, right? So this matters for our model evaluation. In terms of coffee name, you can see that it has evenly distributed from it's evenly distributed readings across 8 products, right? Which is good, right? No single product is going to dominate this whole pie chart, right? And then when we look at our date, it's going to range at least for a year, right? Because we have our information from 2024 all the way to 2025, right? Being the last form of reading, right? If you're looking at cash type, right, we've seen that 97% of cash transactions in our index one table, right, have already been noted in terms of compared to cash, which is at 2.4%, right? You can also try this for the other CSV file, right? The index 2 file. So I think we can try and do it again. Let's go to dashboard. Let's create a data set. It's for index 2. Oh my, I don't think we had named our data set. I do not think we had named our data set. Just a second. Coffee sales data set. Ah, okay. I think we did. Yeah. Always make sure to check that you had named your data set. So let's create our data set. Coffee sales data set 2. Right, let's go to tabular. Create. Oops. Cancel. Let's cancel that. As it's creating this, let's create the other one, the forecasting model. And voila. Right, we're gonna use it from our BigQuery. Index 2. Select. Click on continue. And again, right, you can generate statistics for this, but in the interest of time, right, we're just gonna skip on this. But if you want to read the information that you can get from this, kindly click on generate statistics, and then we can move on forward, right? Okay, so where's the one that I created mistakenly? Go and click on that, and I'm gonna click on delete. Okay, so now we have our coffee sales data set, the first one and the second one, right? So now we are left with feature engineering in our BigQuery, right? So we're going to use BigQuery SQL to create views that extract predictive signals, right? So as per definition, raw data is rarely ready for a model to use, right? We need to transform it into features, right? So for us, these are the columns that are going to capture patterns, right? The model is going to learn from, right? So for our time series sales data, this is our most powerful features are what we call temporal features. This is us being granular by saying we need insights of the day of the week, we need the hour, we need the month, we need the week. For lag features, remember we talked about lag features. Lag features in layman terms, we want to find out, right? We want to find out what the sales were yesterday, right? 7 days ago, because today often rhymes with the same day as last weekend or last week, right? So if today is Monday, there was a last week Monday, but there's also a Monday for next week, and so on and so forth, right? For rolling averages, what we're trying to look for is a smoothened trend between those past days. So we're mainly focusing on what has already happened. Look at our data set. Our data set is information spanning from what had already transpired before, right? So our lag features and our rolling averages and temporal features. So again, just to go over them. When we talk about temporal features, we're talking about the day of the week. So are we talking about a Thursday? Are we talking about a Tuesday? Are we talking about a Saturday? Right? When was it sold? Is it in the morning? Was it in the noon? Was it in the evening? Like, what's the fan favorite product for morning hours? Is it an espresso? Right? What is a fan favorite during rainy days? The month, right? If you know the month and you can even track seasons, you'll know what's a fan favorite for weekend consumers. So that is the temporal features. When we're looking at lag features, we're looking at yesterday's sales, right? What happened 7 days ago? What happened 30 days ago? What happened 5 months ago, right? And we don't want to confuse it with what's happening today, right? Because what we're trying to do is predict for today and tomorrow, okay? Then rolling averages is finding a smoothing trend, right? Can we find a pattern, yeah, in what had happened in the records that had passed from the last 7 days, 3 days, 1 week ago, okay? That's what we're trying to find out. The trend in between. So rolling averages is the trend. Lag features is what happened yesterday. Temporal features is when exactly, right? Like when in terms of, is it the hour? Is it the day? When? Okay, the weekend. So as a standard practice, I want us to know that we're going to be working with tables, all right, in our BigQuery. So let's navigate to BigQuery. As a standard practice, as I was saying, ensure that when you're working with information, right, you need to keep our raw tables untouched, right? Our raw tables untouched. I'll show you that in a bit. So we need to keep our raw tables untouched. So for us to create our views or creating a new table for engineer data, this way we will always be able to go back to our raw files and do these experiments again. Information that we want to get more information out of later, right? Because we're going to try and change it. We're going to try and give it meaning. We're going to try and remove the noise, right? For our data sets, in terms of data set, especially when we're working with models, we like the chaos. We like the dirt, right? Because in that dirt, you always find key information. You will always find, gems hidden in the dust, right? So ensure that you're not working on top of this, rather you're referencing it. Okay, awesome. So let's navigate to our index one table and we will be querying it. So this daily aggregate table is going to show us transactions from a daily level. So one row per day. So sorry, one row per day per product, right? So that is the grain that we will predict at, right? So go to your BigQuery, and then we're going to go to our SQL editor, right? And then paste an SQL query that I'm going to show you. So it's no problem. Let's click on that. Let's scale this. All right. So I'm gonna go table. Let's click on query. Feel free to use Gemini. Feel free to use Gemini. It's there for your practice, especially if you're not really confident. Okay, sorry. Especially if you're not confident in your code. So we're going to call this coffee sales to represent index one. All right. And we're going to reference it from index one, the table from index one. So let's run it. What we're going to see is that it's going to build something on top of our table. Okay. So let's run it. As you can see, I run it and coffee sales one exists, right? Coffee sales one exists, so we can go to the table. And what we're trying to see is now we have a new table called coffee sales one, right? In terms of getting our granular data in terms of daily level transactions, right? So our sale date, coffee name, number sold, daily revenue. Yeah. You can feel free to call yours anything else. It's daily sales, coffee sales, whatever. Yeah, but let's stick with coffee sales one. All right. So now next thing we're going to do, we're going to create the feature view, right? This is with lag and rolling averages, lag and rolling features, sorry. And now we're going to add the predictive features of lag values and rolling averages as a view on top of our coffee sales table. All right. So let's query this. So go to your coffee sales table and query it from coffee sales one, which is great. Then I'm going to call this, let's call it training features. Features, right? Let's call it training features. So just one last check. We're going to create our feature view. We're going to look for a lag. We're going to look for our rolling averages. This is what it's going to be called. It's going to reference it from our table and we can run it. It's going to create it here as well. There we go. Awesome. So we can go to view, or we can even just click on it straight. And there we have it. Our training features view has been created, right? We can just go to the preview tab to see the lag and rolling columns. Select field. Let's click on this. Let's click on this. Click on this. Let's click on this. Let's save. Now our information. Okay. All right, let's go to schema. Sorry. Okay. So we can even go further with this, right? In terms of creating a richer view of our transaction levels to include hours of the day and payment type, right? You can follow along, just it's an optional way of getting at it because we are trying to see when these things are happening, right? How do they pay it, right? Do our evening consumers or customers prefer cash or card transactions, right? And which hour of the day are they most, visiting us at our coffee shop? All right. So again, we're gonna query this, query that, and as a standard practice, always ensure to build on top of each and every one of them, right? So again, remember I told you we cannot build on the existing raw data because it's going to mess up your whole reading, right? We want the noise from this so that it can give birth to active information, right? So let's continue with our query. Oh, sorry. What seems to be the problem? I think I know what the issue could be. I think I know what the issue could be. So I think it's a naming issue. Sorry, guys. Hold on. Just a second. I fix this. Okay, so let's go to our SQL editor to train a linear regression model entirely using SQL. So first, we need to create an encoded version with the features. So let's go to SQL query. And when I just to write this, I'm using Gemini just to correct my code, just so that it can run properly. So what we can is top, erase that one. So this is the same code, but Gemini has pretty much fixed it, right? Copy sales, our table, training features, awesome. Okay, from our project, from our table, from our training features. All right, so let's run it. Let's go to the table. Let's go to preview. As you can see, we have so much rich data that we can use in terms of rolling averages and lag values. Coffee ID. You can see the days of the week, card transaction, right? Right. So it's scattered data, but it's meaningful information. All right. So now we want to train our big query ML model, right, with this information. It's going to take about at least 5 minutes, and I'm going to see how well it's going to do. All right. Just a second. Okay, so let's go to the home page. Close this. Go to SQL query. You can use this Gemini to clean it up. can go to our model and I need us to evaluate our model. Sorry. It's a test. So we're going to select everything from machine learning evaluate, our sales model, this, select all, generate predictions, explain future predictions. All right, so it's going to use our coffee ID, day of the week, weekend, month, our lag values and rolling averages from our project, our initial table, our training features encoded on this specific day. All right, so see, let's see how it does. And it's a success, right? You can view our results. As you can see, we have our predicted number of items sold. Right? Because we didn't really include it, but the day of the week, we had a sale on the weekend as well. In the month, that product specifically, the lag values and rolling averages. So awesome. So our model is healthy and it can make feature contributions according to what we would like to query it later. Right. From here, I want us to jump into Colab and work on a few things before we start talking about security and identity and access management. Right. So we want to understand what we mean by our notebook environment setup, right, in Google Colab. So we are going to interact with Python in our coding environment. And most people who have done programming before, I know you've worked with IDEs and you will need to install a few things here and there. But the cool thing with Colab, which is, let me show you. Just a second. We can either work with Colab externally, or we can create a new notebook to work externally, as we said. You don't really need to navigate here, but this is just something that we can do, right? So Colab is your IDE where we can start coding, right? It's powered by AI and has a lot of things running in the background. So this is just an example of how it's supposed to look like. But going back to where we were, right, we are going to understand that Colab is a free cloud hosted Jupyter notebook environment. So that means it runs on Google servers. So you don't need to install Python or any other libraries locally, because I know that's very taxing, especially on your computers. Very taxing. So we can either open up a new tab to go to collab.research.google.com, or we can work with Notebook here, right? As you can see, we have access to notebooks, right? So it's very easy for us to work with, and we can name it as we can name it according to what we want to name our machine learning model. We can name it this copy ML, or we can have it here. Create a new notebook, empty notebook, and voila, it's the same. All right. So what we'll be learning is we'll be doing within the cells, right? We can click inside the cell to edit it. We can say print hello world. Anyway, it's intuitive. It knows what we need to be doing next. Another option, we can work with a production grade alternative. So I want to say for more control, for more security and integration with the Google Cloud Platform services, we can use Vertex AI Workbench instead, which is closer to a real production ML engineering environment. So we can navigate to Vertex, just leave. So we can go to Workbench. We can create a new instance. So this is where we need to be. We can create new, right? If we don't have any instances, but this is just going to lead us to creating an instance where we can create a notebook where we can host it under the same region, right? And we can choose the type of hardware, right, that runs beneath it, right? We can leave GPU alone for this lab, and pretty much takes you a few seconds to create it. But this is something that Mr. Moffat is going to work us through when we are doing, or rather when we're training our model. So from there, I want to say thank you for joining our class. I will be now progressing on to the other part of the slides. Just a second. Okay, so in closing, I want us to focus on a few things and then let's get ready for our next class. So we want to understand the identity and access management rules and data access controls. So this means like who can read our information, right? Who can modify, who can train, right, on my data, right? And how do we enforce different controls in terms of accessing this data? So first we have to define identity and access management, right? It's how Google Cloud controls who can access which resources for machine learning projects, right? So getting this wrong is either a privacy violation or a blocker in your pipelines, right? Remember when we were creating these instances, we were getting those, pop-ups like, would you like to confirm on this, right? That is a level of security control that's asking you who can access this. Is this a public or a private entity, or rather a private instance that we're working with, right? So let me show you how, or rather where we can navigate with this specific tool. Let's go to the hamburger menu, or rather navigation menu. We're going to look for I am an admin. Let's click on it. There we go. So you can navigate to your roles, and here you will see a list of principals, right, from people, services, service accounts, groups, and their roles, right? So these are things that one we will be able to understand who can do what exactly. So here, since we've not really, is that place where we can write BigQuery? Hold on. Okay, BigQuery. Okay, there we go. BigQuery data viewer, right? So when we click on that, we'll be able to see the description of what can be done, right, in terms of what it allows. So we'll see, is it able to read, right, or query tables? So when are we able to use this, right? So our data analysts, when we're exploring data, what can you not modify, right? So this is only view privileges, right? So these are the 21 permissions assigned that you can get to do, right? We also have the query data auditor. Let's see, data editor. This is who we need, right? For BigQuery data editor, we'll need to reevaluate their read, write, create permissions when it comes to them reading, writing, creating tables, right? So for our data engineers, right, this is for you to understand when you're building your pipelines, right? There's many other roles like BigQuery job user, right? This is a person who is allowed to run queries, but it's required to use or execute SQL only. So anyone who runs queries can combine it with the BigQuery data view as well. So this is as much as they can, right, to try and do. So some permissions might be associated with and checked with third parties. So these permissions can contain third parties and services, domain, whatever. Yeah. So that's pretty much how we want to go about it. So a scenario, okay? When it comes to privacy, especially with what we've been working with, let's look at our card column data, right, in our index.csv. It has to contain anonymized information, as you saw from the dataset that we were working with. Yeah. If we can, if you remember, I can show us just a second. Let's go to BigQuery. Let's go to index one. Let's go to card. Okay, sorry, that's not the place I wanted us to go. Anon. This is what I mean. So we have index one containing anonymized card data, like this anonymous 00000. So in a real data set, we would be interacting with the real card numbers, real customer data, so which is classified as PII, that is personally identifiable information, right? There's numbers of ways to protect it, right? Especially using BigQuery, right? One can pretty much run a query saying, in terms of best practices, we want, let's close this. In terms of best practices, we want to create the identified view that excludes the card column, right? So for our data viewers, you won't be able to look at the card column, right? It can only be shared with the analysts instead of people accessing the raw table itself, right? So we're going to be selecting it from date time, cash type, money, right? So the card column is intentionally excluded because it contains PII, right? So grant viewer access only to save views from the row table, right? And we're going to be able to know that index one sharing has permissions, right? We can add principals in terms of pasting our email and assigning a BigQuery data viewer role, right? In terms of showing who exactly can access this, right? They're like, who provide me your email so that I can give you the access to. It's pretty much like I think we've all interacted with a lower level access control feature when we are working with like Google Docs, and then it's asking you like who has permissions to check A, B, C, and D, right? So that is basically right what it's talking about. So this is just one way to protect our information, and it's very key, especially when we're trying to protect information of our customers, right? Or rather, ensuring that our information in our pipeline and in our teams, across our teams, only select people have access to the right information. Okay, so just to run it down, our key takeaways from our session last week: collaboration is the number one success factor, right? Our AI failures are organizational, they are not algorithmic. We can't really blame the tool. We have to look at those who are in charge of it, right? We have to version everything. So from our data sets, right? Data set versioning, our models, right? We have a Vertex AI registry, right? Using GitHub as well in terms of, remember the repository and team collaboration efforts that we could do there, right? We have to communicate changes before they happen, right? From our business analysts, ML engineers, data contracts plus model release notes protect downstream teams, right? Governance is a major needed part of the equation, right? We have to include at the back of my mind, right? We have to include acts like the EU AI Act, GDPR, that's General Data Protection Regulation Act, that runs within the EU, HIPAA if you're working with medical data, right? And then assigning one owner per data set and one owner per model, right? This is going to help us track. It's going to be able to be audited. It's going to increase on non-repudiation. Like it's easy for us to ask what happened, when it happened, and we have an identity as to who has access to it, right? We can monitor it continuously, right? When we talk about data drifting and concept drifting, these are things that silently kill our models, right? So we have to put in checks to see if is it making sense, right? So we have to set automated alert thresholds. Then lastly, we have to enable processes, right? That is using tools like MLflow, dataset versioning, GitHub, right? But ultimately, culture and process must come first, right? So we are now done with our session, and feel free to ask questions in our group so that we can assist us in pretty much doing our assignments and also ensuring that each and every member of this community is well equipped to become the next AI billionaire for tomorrow. So I'll be waiting for us during the next class. I'll be joining, and see you guys soon. Thank you very much. It has been a wonderful time. Thank you.